In a previous video, we covered the ideas of mutually exclusive versus non-mutually exclusive probabilities when we see the word or. In this video, we're going to focus on independent compared to dependent probabilities when we see the word and. We're going to go back to this two-way table about cats and dogs and where people are from in the U.S. To discuss this. To begin with, a couple of definitions. We'll say that independent events are not associated, which means one event has no effect on the probability of another event. If the first event occurs, it doesn't increase or decrease the probability of the second event. Rolling one die and then rolling a second die are independent because what you get on the first roll has no effect on what you get on the second roll. Those would be independent. On the other hand, dependent events will say they are associated. So one event does have an effect on the probability of another event. For example, if you draw a card from a deck of cards, don't replace the card, and then draw another card, that's going to be dependent. Let's say you want to get 2 aces in a row. Well, probably the first ace would be 4 aces out of 52. But if you leave that card out of the deck, the probability of the second ace has changed. It's no longer 4 out of 52, but there are just 3 aces left in the deck because you've taken one out. And there aren't 52 cards, but you're down to 51. The first event changed the probability of the second event. Mathematically, you can test for independence with this formula. 2 events, A and B, are independent if the probability of A given B is equal to the probability of A. And let me use the two-way table from above to explain this a little better. So example 1 says, from this two-way table are the events of having a cat, I'll call that A, and being from the south, independent or dependent. So for this first probability, the probability of A given B will be the probability of having a cat given the person is from the south. So given from the south, it narrows down the sample space to 450. Not everybody is from the south in the survey, only 450. And out of these 450, 115 have a cat. If I calculate this, 115 divided by 450, and that gives me 0.2556. I want to compare that to just the probability of A. That is probably that a person has a cat. So that's everybody. There's no condition to narrow down. I'm looking at all 1,000 people. The number of people with a cat is 250, and I get 0.25. And so these are very close, but they're not exactly the same. This is 25.56%. This is 25%. They are not equal, so they're not independent. Therefore, they are dependent. One has an effect on the other. Maybe being from the south slightly increases your chance of having a cat based off of this data, but they aren't independent. One is having an effect on the other. Another example not related to this two-way table. It says, consider a standard deck of 52 playing cards are the events of drawing an ace, event A, and drawing a diamond, event B, independent or dependent. So let's start with the probability of A given B. That's the probability that you get an ace given you drew a diamond. Now I'm given I have a diamond, so there aren't 52 possibilities. But since I know it's a diamond, there are only 13 diamonds in the deck. And out of those 13 diamonds, only one of them is an ace. There's an ace of diamonds, a king of diamonds, a queen of diamonds, a jack of diamonds, all the way down to a 3 of diamonds and a 2 of diamonds. But there's only one out of those 13 that's an ace. As a decimal, as we've seen before, this is 0.0769. Now we just want to look at the probability of A. No condition, no or, no and. What's the probability that you get an ace from a standard deck of cards? Well, there are 4 aces in the deck. There are 52. This is 1 out of 13, which also equals 0.0769. So I got the exact same results. And when they're the exact same, when they're equal, they are independent. Right? This is how we can mathematically define something as independent or dependent. And you need to be familiar with this formula, especially for test 2 in my class.